Hi, this is Laptop Radio at KZSU Stanford 90.1 FM. Today, in a few minutes, we will have two guests, Walter Mock and Glen Speckert. Today's topic will be nuclear fusion and what it is. So we're going to talk about the basics of nuclear fusion. So, Walter and Glen, can you introduce yourself?
Who first? I'm Walter Mock. I'm a scientist working at SLAC National Laboratory. I am a specialist in optics, so I do everything related to optics. Currently, my research in X-ray optics. My main interest is doing science for the good of the people.
And I'm Glen Speckert. I worked at Livermore Labs on a magnetic fusion project. I'm currently working with startups on artificial intelligence.
DJ Solmaxion wants to insert here. Now, why are we having Fusion 101 today? Because next week you all have a conference?
Yes, we have VLab.org is a nonprofit organization which is bringing together three startups in the fusion energy area. Tri-Alpha, General Fusion, and Lockheed Martin, of all people, has a magnetic fusion device.
I am Walter Mock. I'm a secretary of the conference called Commercialization of Nuclear Fusion Summit 2017. It is a three-parts program. There will be 3 sessions. Session 1 is about the technical session, unconventional nuclear fusion. There will be presentation from the 3 major startup company. And the second session would be what we call the enabling technology for nuclear fusion. Now, a lot of people knows about nuclear fusion, but they don't know about what technology need to be developed in order to make nuclear fusion work. That has many, many aspects. For example, like superconducting magnet, use AI, computation technology to control the experiment, find out the best parameter to run the experiment, accelerated physics, which accelerate the charged particles, and cryogenic magnetic field to produced by the superconducting magnets. This is a second session presented by the brilliant staff of Stanford University and SLAC. The first session would be business and economic. Now, you have the technology, but you have to run it like a business, not like an academic, so that it can be successful and benefit people.
So I feel really privileged to have 3 experts in the clean energy and the energy field here today. DJ Solmaxion is an expert in sustainability as well. So I wonder why nuclear fusion is important. I mean, like, what is it? Like, is it some physics stuff? I mean, what, in just lay language, what is nuclear fusion?
Fusion is what powers the universe. All of the stars, all of the suns make energy with fusion. What we're trying to do is put a piece of a sun in a magnetic bottle and be able to extract the energy in a simple and continuous manner instead of all at once.
Now, fusion is about putting 2 atoms together, fuse them together. Now, the finishing atom actually has a mass less than the component's mass of the component atoms. So there's some mass missing somewhere. Now, according to Einstein's formula, E equal to mc squared. So whatever the mass miss becomes the energy. That's how the kind of energy the universe uses to power the sun.
That sounds very interesting. I mean, people say that nuclear fusion is just so 20 years ago. Why are we talking about nuclear fusion now? Or why are we talking about nuclear fusion today?
Well, Michel, we went to the moon on 2K of memory. The computers that we used when we had those big rockets were way different in the ratio of physics to computing back then. Similarly, fusion has been around since the 60s and 70s, and all of these machines had very little computational support. Today, you can model all the way down to the individual atoms. You can collect tremendous amounts of information, and you can make sense of it. So you can not only control these processes much more efficiently, you can better understand what's going on, you can predict what's going on, and AI is the key to doing that.
Glenn is so correct, because in the AI, we can move nuclear fusion to a new era. Now, besides that, we all heard that the 14 years old can make nuclear fusion. But he could make a nuclear fusion, but he could not scale it up to generate a lot of energy. Now, nuclear fusion, there are 3 issues in nuclear fusion. Number 1, bring it up to high temperature, we call ignition. The second is when you have a high temperature charged particle together, you have to contain and keep it in one place. So we call it confinement. Now, we can confine the charged particle in one place, but we want to sustain it for a long time in order to have a machine to generate electricity continuously. So we call it sustainability. So scientists have been struggling with these 3 problems. In the past, we think that, we know how to do nuclear fusion in a small scale, like a 14 years old would do. What we can do is just scale it up, make it bigger and bigger. I used to love it that in order to make nuclear fusion work, probably we have to build a sun, something as big as a sun. Now, however, in the past 5 years, people think out of the box, and they discover there are new ways to handle these 3 problems: ignition, confinement, and sustainability. That's why nuclear fusion become an important aspect of investment in nowadays.
Confinement, of course, can take many forms. There's different shapes of magnetic bottles. Everyone has probably heard of the tokamak, which tends to be like a donut. But there are some other very much more innovative physics geometries for containment. And if you come to the event at Stanford Campus on November 14th, you'll be able to talk with these startups and understand in more detail their approach to confinement.
So I in the age of artificial intelligence, of course, where it's just everywhere in the news, you can't escape it. It's on the web, it's on TV, it's on Twitter. Everyone's talking about artificial intelligence. Has AI really changed the subject, the study, or the commercialization of nuclear fusion?
Yes, so much so that even Google has a fusion effort these days.
Well, AI has changed it quite substantially. There's a collaboration between Google and TriAlpha for the past 3 years. Now, what Google did is they talked to the physicists and find out what the parameters in order to operate the nuclear fusion machine, and they, based on the input they have, they model it and try different parameter with the computer technology, and they find out how to optimize the experiment, and they can go into the area of operation that could not be imagined before and get very good result.
So now that has theoretically been done and fully optimized, but has that actually been demonstrated?
It has been demonstrated. Actually, there was a talk about 3 weeks ago at the Department of Physics, Stanford University, given by the principal investigator from Google.
Very good. Sometimes you have to miss things on Stanford Campus. But that's why we're here on KZSU telling it to the crowd.
So when I think about fusion or nuclear fusion, I really think about energy, and I really think about our generations and those generations to come. Would we have enough energy for everyone in the world? There is currently 7.5 billion people on Earth, and that number has been growing every day. So, do we really need to harness the energy from the sun to make, energy or fusion, clean energy?
Ultimately, all the energy is from the sun. The wind happens because the sun heats different parts of the earth differently. Solar energy, of course, is direct from the energy of the photons. And putting the ability to harness nuclear energy into the mix gives you some very nice options for locating small plants near where you need large amounts of power.
Well, besides that, we find new sources to generate energy. I think conservation is also an important aspect of energy management.
So Dr. Mok, can I ask, now next week, if you come to the workshop here on campus, where's the location of the? Where's the location?
The location is at the Hewlett Teaching Center, room 200.
Ah, excellent. Okay, so great auditorium for all the public. The public can come. Yeah. So you're an expert. I want to know. Tell us how many, government and large-scale consortiums are there out there right now working to build fusion reactors?
Besides the
startup ones that you're going to witness.
I also want to add one more thing. Stanford student comes to the conference free, and also with very good food too.
Oh, okay, good food. Yeah, and if you look like a Stanford student, I don't think anybody's going to deny you access.
Oh, you're going to need a student ID.
Now, in terms of the government effort in nuclear fusion, as far as I know, there is very little activity in U.S. government. Most of the money will be poured into the European project called ITER in France. So a lot of people think that the project is too big. It costs too much. It sucks out too much money from our basic R&D in nuclear fusion. Now, therefore, happily, and I think it's patriotically, the 3 billionaires start to put their money in, Jeff Bezos, Peter Thiel, and Paul Allen. So they put on close to $500 million into the project. And also Goldman Sachs invests in it too. So you see that when the government is not working in nuclear fusion, the private industry see the light and they chip in.
And I wouldn't call each of these reactors. Each of these is a prototype, an experiment, an integration, pushing the frontiers further back. The other large fusion effort that, of course, we should mention is the NIF, the National Ignition Facility, driving inertial confinement fusion, yet another way of confining the plasma.
Yeah. I want to add one more point about the how private enterprise work. It's very different from the government project or academic. My background actually is in aerospace industry. I work for the government to build missile seal and this type of work. Now, in government work, if you don't meet the goal, you can extend the project. In the private enterprise, you have to meet the milestone. That put a lot of pressure on the inventor and the people who work on the project. I think this is a good thing.
So this is DJ Laptop. We are listening to KZSU Stanford 90.1 FM. Again, we have here DJ Solmaxion, Glen Speckert, and Walter Mok. And the topic is the basics of nuclear fusion. So if you wanted to tweet to us, you can tweet at KZSU or laptop/_radio. And if you have any questions you wanted to ask the experts here, please just go ahead and tweet us. So I wanted to just really go a little bit deeper on, but not probably that deep, because it was an honor to really meet some of the speakers at the conference, and it was really interesting. I saw some of the presentations and some of their products, and one particularly is one of the VC, Ray. He mentioned that it takes a long time to create such a product, right? So why should we care? And why would VCs invest in clean energy?
There's certainly a component of responsible investing. That these are not your typical investors. Paul Allen and Peter Thiel and Jeff Bezos have more than the average amount of money and are doing something to change the world in a positive manner, and that includes funding a inherently long-term approach such as nuclear fusion.
And energy security is a national issue. Only we need to have energy security in order for United States to have freedom.
So I have a question for you, Dr. Mach. Is this fusion, can you describe the fuel of the fusion?
Fuel?
Yeah. I mean, or typically, if a electricity generation plant, there's always like a fuel involved. And so I think it's important for our listeners to want to make that analogy and understand how fusion works in reference to what is it really fueling off of.
Okay. Now, imagine you have two hydrogen atoms. Hydrogen atom is composed of a neutron and a proton. So they fuse together, then two hydrogen atoms fuse together, become a helium atom. The helium atom will have two neutrons and two protons. Okay. Now, in the process of doing that, they lost some mass, and the mass missing will become the energy released in heat.
And it turns out there's other fusion reactions that are not with hydrogen, but all of which share the characteristic that if you add up the mass of the particles you start with, it's some of that mass is converted into energy by the time you get to the end results.
So this talk is really about the basics, and I don't think we can talk about nuclear fusion without talking about some physics and chemistry. Mm-hmm. So what are some of the elements involved?
Well, hydrogen, he just named off. The most ubiquitous element of the universe. Yeah. So, yeah, there's plenty of hydrogen out there, but hydrogen is also very, it's difficult to capture or manage sometimes, but that's nothing that we haven't already overcome because the whole of the Apollo program is all hydrogen and oxygen fuel tanks. So the hydrogen shouldn't scare anyone out there. This is like well understood commercial gas. Yes?
You can turn the hydrogen into helium in some of the main fusion reactions, and put the helium in a balloon, and you talk funny.
Talk funny or rise high in a helium balloon.
But the point being that you don't have it's a much safer reaction. If things aren't working, then it just stops, it quenches. And you don't have the possibility of a meltdown. You don't have the possibility of long-term radioactive sites. So it's healthier for the environment, that sort of thing.
Yeah, no 3 Mile Island meltdown, because this is not fission. So not to be confused with fission. I think it's always, for those of us out here dyslexic, sometimes we mix them up. I do.
I thought it was food at first, and sometimes people confuse that with autodesk fusion. But no, we're talking about nuclear fusion, which is clean energy, clean, clear, and safe energy. And we are changing the future now, or actually we are creating the future, not changing it per se. I know that this event that you guys mentioned is going to be next week on Tuesday, the 14th, and is hosted by SLAC, right? Stanford, and VLab. What is VLab?
VLab is a nonprofit organization, formerly the MIT Enterprise Forum. It's a group. If you go to vlab.org on the web, you will see the current event, but also a large history of various different events in the Silicon Valley. VLab's charter is to bring together the state-of-the-art in technology as well as venture capital and entrepreneurism.
Management.
Okay, so with us today is a representative from SLAC, who is Walter Mock, a scientist there. And one of the other partners is the U.S. Asian Tech Management Center, who is partnering with us as well. So it is really 3 organizations. And it's a special event because 3 out of the hottest 4 nuclear fusion companies are going to be together. I don't know what they're going to do, but it just sounds really cool. And it is a very special event. Tell us, Walter, about SLAC and, whether you guys do nuclear fusion there or not. Just explain a little bit.
Well, I organized this event purely through with personal interest. Actually, I have a partner in crime at SLAC working with me in a technical program, who is Dr. Seafry Glenser. He's the head of the high-density plasma research group. So we do have a fusion program, but we work on it kind of secretly, and we take a different approach to deal with the plasma.
What is the difference between fusion and plasma? All I know is plasma is blue and fusion is red.
No. Go ahead. Now, plasma is an atom with the electron stripped off. It becomes a charged particle that they call the plasma. So a aggregation of charged atoms is called plasma. Okay.
Plasma is another state of matter. There's solid, liquid, gaseous, and plasma. Fusion is a process. 2 plus 2 equals
1.9.
1.9. 3.9.
So fusion is a process?
Yes, fusion is a process involving atomic elements, and a plasma is a state of matter.
So what is the process for nuclear fusion then, if fusion is a process?
You get the ingredients hot, you mix them together, and you compress them, and you get them to recombine into a different set of atoms. And as we've said, the sum is not equal, and that difference comes off as energy. There's lots of different ways to do this. At Livermore, they take 192 lasers and smash them from different angles into a small amount of fuel and get it very hot, and the outer core eblates out, which makes a tremendous compression wave, which compresses it many orders of magnitude. And you really need to get to these very extreme corners of the universe, the kinds of conditions that are normally only found inside the sun, in order to make this happen.
Well, in the past 5 years, they have new technique to compress the charged particle together. One way is to accelerate two bunch of particles in opposite direction, just like running two cars with a head-on collision. So that's one way. Another way is you have the plasma. You keep hitting it with another type of charged particle. You can bombard it with other particle. It generates the heat. That's another way. This is the way used by Lockheed Martin to produce a compact fusion machine.
You know, Walter, when I look at accelerators that have been around, Einstein and those guys, it was the turn of the century and before the war that they were inventing all of this. They had no computers. They had a pencil and paper. And still they built huge machines, accelerators, and slammed particles together, and just barely had enough computation to understand, to gather data of what's coming out. It really is no wonder that as the computer technology suddenly enhances what you can see as well as what you can do, that now we can really begin to tame these corner cases of the universe.
So I call that convergence. Just in really different areas like AI, GPUs, CPUs, VR, AR. And then you have like other technology that makes it more cost effective to build. So I was just wondering for fusion and making a nuclear fusion, what kind of equipment do you need to make one? Can I do it at home?
In my garage, I wouldn't recommend it, but I'm sure there's somebody out there trying.
You could do it at home. As I said, the 14-year-olds in England built one, but it is in a very small scale. You can't see a flicker of light and then it's gone. That means it's not something applicable. Now, talking about AI and computer technology, let me give you an example how it accelerates the development of nuclear fusion. The technique used by a company called General Fusion requires synchronized hammer to push the charged particle together. Now, before, in terms of electronic, it's very hard to have, for example, like 10 hammer activate at the same time, hit at the same spot. But because of the computer technology, we can do it. So the old Navy pattern becomes a reality, which could not be done maybe 20 years ago. Now they could do it. That's why we have new technology in nuclear fusion.
I don't think there's too many garages that have startups that are experimenting with nuclear fusion, primarily because of the cost and you need some major magnetic fields and some major power and very focused efforts.
So I have a question. In any of these processes, when they create the energy, is there like a release of gamma rays or anything that would be harmful to us?
Gamma ray itself is harmful, but we actually have very shielding to absorb it to generate heat. We make use of the gamma ray. That is one of the techniques that in the Lockheed machine is using it.
And the Tri-Alpha machine is a colliding beam accelerator, as I understand it, where they're really trying to take advantage of crossing two beams and without a policeman at the crossing, everything collides and boom, get a lot of energy.
Now, I give a very simple explanation how the Tri-Alpha machine works. Imagine you have two smoke rings far apart, smoke ring of plasma, and then you accelerate, slam them together at the center and form a glove of plasma. But after forming a globe of plasma, then you must charge it with two particle beam in opposite direction, so it's spinning like a top, then it becomes stable and confined. This is a very ingenious technique, never experienced before, and it worked.
It's like having a Frisbee and tapping it on both sides to keep it spinning.
Very good.
So I actually want to make like a very simple one because I'm imagining that I'm like 15 years old, you know, a lover of science and physics and biology. And, you know, I have ordered gallium on Amazon and make fidget spinners from gallium and watching YouTube videos. So I'm really inspired by the 14 years old, and I wanted to go out and buy some simple widgets from Amazon and make myself a nuclear fusion. What do I need to do that?
Well, I don't think Amazon is selling fusion kits, do-it-yourself, just yet. But if you do the right Google search, maybe you can find it. I don't think that's a doable do. Fusion is not something that 14-year-olds can do. Again, we're pushing back the state of the art. We're trying to understand how to make it happen. And you know, there is not really a design for a reactor. There is a design for lots of experiments that push back the frontiers of knowledge.
So I wanted to go into the significance of nuclear fusion now. Just to be more on a serious note, why is nuclear fusion significant? You know, why do we care? I mean, is it just clean energy? I mean, do we have other energy sources that we can use that are easier to do? You know, that might be a little bit more cost effective. You know, that doesn't require us to harness the energy from the sun. You know, or maybe less harmful to humans.
It's the amount of energy, the amount of potential energy that's there. You can do the calculations. You can see that there's tremendous potential, and if you can harness that, when we can harness that, then all other sources will pale by comparison. But until you harness it, until you figure out what's the easiest way to open that genie. Without it being a hydrogen bomb. I mean, we have ways to make nuclear fusion, and that's hydrogen bombs. But you want to take it out slowly in a controlled manner.
I want to make one more point why fusion energy is so special. Because the amount of fuel used in nuclear fusion is relatively small compared with other type of fuel. In other words, if the nuclear fusion works, we have a fusion reactor. That means we can put it on a spaceship and explore the star.
Well, I had to bring it back down to earth here. So I think it's important for listeners all of us to always never forget that there's really two forms of energy that we use in our daily lives. One is electricity, and one is transport fuels. And right now, you know, so electric cars, you start seeing more and more electric cars, which then drive the need for electricity, like a changeover from the actual diesel, gas, jet fuel that's coming from fossil fuel-based natural resources. So now we have, let's just call it crude oil. So now we have a barrel of crude oil. And versus, you know, whatever the energy is that's needed to make the fusion reactor happen. But the key point is that fundamentally, we as a society, we actually use an enormous amount of transport fuel. And so I think, for me, the biggest thing that a fusion reactor can do is if you call into Tesla, and you say, yes, but Mr. Tesla, that would be Elon Musk, we would say, but you know, you're still causing your electric cars still have to be fed by either a natural gas plant or however you're making your electricity. Typically now it's what are known as cogen gas plants, and that's still a fossil fuel. So your electric car is still driven by fossil fuels. 74% of greenhouse gases are caused by the refineries, not your tailpipe. That's a hidden fact that most people don't realize. And so I think the hope would be that fusion actually, without the use of any fossil fuels, is going to enable encroachment upon that very large, it's about a $4 trillion per year industry to supply transport fuels, meaning the fossil fuels for our cars and transport, freight, our supply chain, et cetera, et cetera. So, I think the biggest, I like to call it life without oil. So potentially fusion can bring about life without oil would be the way I would want to call it out. What do you think, Dr. Mock?
If many people have seen the movie Back to the Future, and there's a little fusion machine in the magic DeLorean car, and they throw a banana peel in, and it's good for another week of energy. It's much more likely that the fusion's going to come in, being able to support a city, being able to support a ship, being able to support a spaceship, as Walter said, or really, it's fixed facilities that you don't have to put a lot of mass in, but you get a lot of energy out, and then you're going to transport it out, I'll say on wires, but if there's wireless transportation of energy, you can do that too.
These are very good points that with fusion, then we can live without the oil, without the carbon footprint to worry about. Now, as a matter of fact, when we are talking about the fusion, we already know people are working on another type of fusion machine, which may be able to generate electricity directly. So we can skip one step from heat to heat exchanger, dry the turbine, and generate electricity. With this type of fusion machine, generating electricity will become even more efficient.
Hi, this is DJ Laptop. We are here at KZSU Stanford 90.1 FM. We are with DJ Solmaxion, Glen Speckert, who had to work on the nuclear fusion, as well as Dr. Walter Mock from SLAC here, and they're speaking about fusion because they are hosting an event called Nuclear Fusion Reacting to Commercialization on the Stanford Campus in room 200 next Tuesday from 6 to 8:30 p.m. And if you guys have any questions again, please tweet up your questions to us, and we will answer them.
And you can get tickets if you go to VLab.org, and there's a special category for Stanford students. And if you're not a Stanford student, there's a category for you as well. Find your category, buy a ticket, meet the pioneers, and ask them questions.
So now we have like about 5 minutes left. So I wanted to ask you guys to talk about the significance of energy. I know that we touch up on that topic for a little bit. So is this sustainability? Is this clean energy? Is this just physics? Why should an average person care?
Yeah, Dr. Mock, will it change the price of my electricity bill?
Well, I haven't done the number, but in general, in the economic theory, the larger amount of user for a certain product, then the price would come down. So I think I would safely answer your question that the price of electricity would come down.
I had a question to ask you. What do the experts estimate as when will we start seeing the true commercialization of fusion? I guess it's going to be a topic and a hot topic at next Tuesday evening. So you're coming straight from the labs. When do you all project that we should be able to hit that milestone?
Anytime you're talking about physics breakthroughs required between here and the solution. It's like when you're building the Manhattan Project. You know you're going to get there if you work hard enough, and you know you're working hard. And in answer to when, Well, it depends on what you find along the way and whether you're able to work your way around each and every problem that comes up.
Yes, but I think what is different of what everybody's here talking about today is that your workshop next Tuesday evening has VCs involved, has startups involved. I mean, that's a signal to me that there's a VC that has seen a business plan, and with some sort of feasibility, they're not putting in their money. Yes, it's these what I call them the rocket boys, the ones that have the money to sort of throw at their toy rockets in the backyard. But I think it's exciting that you all have brought together these three startups that are active and have been, I guess some of them are as much as, I don't know how old they are, but I think we all need to come there to find out, because I've never seen a panel of startup companies, and also is the VCs are on the panel as well?
Yes.
Yeah, I find that is what's really exciting about what we're in here talking about today, because otherwise it's just another science project that the federal governments of the world can keep throwing money at. That's because yes, the theory's there, but this is something that's beyond, where there's a lot of people that's taking a lot of time and money to try and to really put the fusion energy in a bottle for you to take home.
So we have some questions from the Twitter universe out there, and the question is from a man named Jerry. He basically asks, we've always have been told that it is 20 years away. What do these startups think? 10, 20, or 30 years?
Well, it happens that I kind of studied their timeline. Now, the one, start with the most optimistic one, that is from Lockheed Martin. They said that in about 5 years, they would have the technology proven and start working on the commercial model. Now, in terms of Tri-Alpha, they finished the first generation machine, and they are building the second generation. So there will be 2 more generations to go before they produce the commercial machine. So that's about what they said. You could ask the same question to them on November 14 and find out what their answer would be.
If you're looking at space travel and you ask the question of, golly gee, can't we recycle these booster rockets? It's something that seems obvious now that you can do it, and it's a real game changer. When you look at why is Lockheed Martin investing their own money in nuclear fusion, well, they see a market. There's a lot of places where if you've got a lot of power, and granted those applications may be a cross between civil and military options, but it's very feasible. Tri-Alpha is very definitely aimed at commercial fusion, and the payoff is big, and the risks are large, and the schedule is long.
So we have another question from social media, and the question is very important. It says, what about byproducts? Fission has CS-137 and ST-90. Are they dangerous? Wait. First, explain what these numbers are.
What was the carbon fluoride? Carbon hexafluoride?
CS-137 and ST-90.
Strontium. So basically, fission breaks a large atom into smaller atoms, which are cesium, which are potentially not stable, and they decay further. And each time it decays, it emits particles and radiation, etc. Whereas fusion starts with small particles generally and builds up to larger particles, and the energy that comes out of the calculation results in you harvest the energy and you have very stable resulting elements.
So that was actually SR-90. So it is CS-137 and SR-90. Are those things dangerous?
We don't have those things. In the nuclear fusion, as Glenn explained, the nuclear fusion is fusing two simple atom together, like helium, hydrogen, and tritium. Those atoms, they are not radioactive. The final product is not radioactive at all.
So I just wanted to tell you a little bit about the event on Tuesday. The moderator is Rachel Slaybaugh. She is an assistant professor of nuclear physics from UC Berkeley. Go Cal. Then the panelists are companies are from General Fusion, Tri-Alpha Energy, Lockheed Martin, and Red Seal. And it is going to be at the William Hillard Teaching Center, room 200 on campus from 6 to 8:30. And you can look at the website on VLab.org, VLAB.org.
I'd like to add a little bit more about the background of Rachel Slaybaugh. Now, she is an assistant professor in nuclear engineering at UC Berkeley, but she is also a fellow of ARPA-E. He works part-time in ARPA, which is Advanced Project Research Agency, specialized in energy. Now, she is from a very mature technology background, which is nuclear reactor. Now, fusion is something new. Now, she's important in the fact that she can look at the fusion technology from a mature technology point of view, how well it will develop, what would be the timeline would be. She would be the good person for moderating this panel with a very objective background and view.
So I think we have about 1 minute left. I just wanted to thank everyone for listening and thank Walter and Glenn and DJ Solmaxion for speaking on this topic of nuclear fusion. I'm very, very excited about the topic. I think is very different, and I think is very special because, in the tech community, people really talk about AI, and they talk about, making games and apps and advertisement companies, but they don't really talk about, the science, and energy and things that will change our future. So I just wanted to thank you guys for coming in here today.
My pleasure. With AI, knowledge is power.
My pleasure. Just come to the panel discussion on November 14th.
Yes, bring your spirit with you too, because that's also power. We can make it happen. Everybody get on board fusion. I'm very excited. It's very exciting. Clean Copper Radio and Laptop Radio. Yeah, we work together, teamed up here just to bring you guys, lots of hot topics. So this is an extremely hot topic. I hope to see a big turnout for you all, and tell your friends and bring your kids and just make a go of it. It's a good educational opportunity.
And if you have any questions, you can go to the VLab website and ask there, or follow them on Twitter at VLab. Thank you.